The next topic is reducing the number of categories in categorical variables. Remember, a categorical or factor variable, when we use it in a model, it's going to generate dummy variables. So if you have k levels, k distinct values for the categorical variable, we need to use k minus 1 dummy variable. So if you have like 50 categories, you end up with 49 dummy variables. So to reduce dimensionality of data, it's beneficial. If you have 50 categories, is there a way that we can reduce these categories into just say 15 or 20? So that's going to reduce the number of variables significantly. So we can't just combine categories without looking at how different they are. If the categories are fundamentally different, if they give you very powerful predictive value because of the distinctions in the categories, then we want to keep them as is. But if the categories are very similar, then maybe it's a good idea to combine them, and that will reduce the number of dummy variables needed. So uh, we have to first study uh, what we have, right? So uh, what kind of categories we have. Okay, so let's look at say we have Zn is one of the okay. So let's say table, right? Bh dot df. This is the zoning variable. So this has so many categories. Is there a way in which we can combine some of these categories, right? So that's what we are trying to do. So what if we plot zone, okay, against well, cat med v. Cat med v is 0 or 1, right? So if with respect, that's a target variable, and if some of these zones have the same pattern for different zones, then that means they can be combined. If they are very similar, we can combine those categories. So um, let's try to plot zone against uh, cat med v. Okay, so we're going to do ggplot, right? Uh, well, we need this table, so we need to capture this. Okay, now in order to plot Zn with catmed v, we have to prepare a table of the data. So we need to say table bh dot df. Okay, we want catmed v, and then we want z, yeah, we want these two. Okay, and this will create a table for us like that, but we want this table to be a data frame. So we say data dot frame. Okay, so that's going to create a data frame like this. Okay, then the names of the columns are var1 and var2, so we really want to change those names. So let's capture this bh dot table dot df. Okay, and then once it is in there, so bh, so we say names bh dot table dot df. So there are 3 columns, right? So we'll give 3 names. Variable 1 is catmed v, and then zn, and then frequency. Okay, how many? Okay, so that's generated the data that we need. So that should go there. Okay, now let's plot. Okay, so ggplot bh tbl.def. Okay, and then we have AES x equal to zn. Okay, y equal to frequency, and then we will use for fill color fill equal to cat dot medv. Okay, so it's going to create a stacked column, stacked bar chart. Okay, um, with the height being the frequency of Zn. Okay, frequency of Zn, but colored by whether cat medv is 0 or cat medv is equal to 1. So we do geom bar and stat equal to identity. Okay, so that's going to build a chart like this. So we have cat medv equal to 1 and 0 and 1. This doesn't help us. What are we trying to do here? We're trying to see which categories are similar so they can be combined, and it's really very hard to see uh, how we can do that. So it's what we're going to do is we're going to convert each of them into into same scale. Instead of plotting frequency, we'll plot percentages. Okay, what percent is 0 and what percent is 1. So that way all of them will have 0 to 100. So it'll be easy for us to see the similarities. So we copy paste that, and then in geom we see position equal to fill. Okay, so now we have 0 to 100%. So we can have a title here, gg title, distribution of cat medv by Zn. gg title. Okay, so now you see it's easier to compare. So now you see that 25, 28, 30 and 18, 85, 70, 52.5, they are all 100% 0. So they are very similar in their differentiation between cat medv of 0 and 1. So they can be combined, and these 17.5, 20, and then 90, 95, 100, they are all same, exactly same. So they can be combined. So this chart gives you a visual picture of how to combine categories as a way of reducing the number of dummy variables that we will need, and that again will result in reduced dimensionality, which is what we are after. Now if the categorical variable is an ordinal variable, okay, if it is a numerical variable, then you can use the ordinal variable as just numbers and not create dummy variables at all. Okay, this is especially true now if you have say grades. Okay, grades, if you use only A, B, C, D, and F are only 5 categories, so it's probably not a big deal. But if you have like pluses and the minuses in each of the grade level, then you can get like 15, 20 grades. Then in that case, you can grade them with the GPA equivalent of each grade and then use that as a numerical variable. So that way there will be only one variable and not like 14, 15 and so on. So converting ordinal variables is good. Another way is if you have, you know, um, if you have binned variables, okay, age has been binned into like 10 bins. Okay, so those are categorical variables. Right? Once you bin it, then it's no longer a numerical variable, and you end up having to generate dummy variables for it. Now, if you don't want to do that, then you can use the midpoint of each bin. Okay, quote the midpoint value. So now that midpoint represents a numerical value, and since it's an ordinal value, then you can use that as just a numerical variable and not a categorical variable. So those are possible approaches for keeping the number of variables for, if it is an ordinal variable, to keep having to uh, prepare dummy variables.